So welcome to class number 5. So from this class we will learn the theory and we will also do the respective lab. Okay. So in this lab we are going to connect two PCs, PC1 and PC2. We give them IP in the same subnet as you can see on the screen. So for PC1 we are giving 10.0.0.1/24 and for the PC2 we are giving 10.0.0.2/24. So this lab we do it on GNS3. So these are virtual PCs on GNS3. For the virtual PCs, if you want to apply the IP address, you need to use this command IP space IP address slash and the subnet mask. Okay. So once you apply this configuration, then you need to save it. So this is important because if you don't save and if for some reason if GNS3 reboots, this configuration won't be there. So only when you do save, the configuration will be there permanently. Otherwise, if this PC1 reboots, it will lose its configuration. Okay, and to verify which IP address PC1 has, you can use this command show IP on the GNS3 VPC virtual PCs. These are just simulating personal computers. It won't have all the graphical user interface or all the commands that you normally see on a Windows or Mac system. These are only just two lightweight instances to test connectivity. Okay. So let's see how it will look it in the GNS3. So first you will take two VPCs into the GNS3 lab pane and then you will connect them using the physical connector. So as you can see here, E0. So this is the network interface card name on this PC. So on PC2 also this is the same name. Okay, so we connected to these two network interface cards using this cable. So GNS3 is like simulation, so these are not real PCs, but the functionality, everything will work as a similar way. So even this physical layer connectivity also works as normal. Okay, so once you connect this, you need to turn on these machines. Once you turn on, if you right click on PC1, it will open the console option for it. So in the console you will see the command prompt similar to the Windows or terminal in Mac. Okay, so first I have configured the IP address in this step. Then I verified to make sure whatever the IP address I have given in the configuration is reflecting or not. So I used the command show IP. Then it will output what the configuration this current system has. So as you can see, IP mask. So whatever I have configured, it has been in effect. And the next important step is to save the configuration. So what happens is when you save the configuration, it will write into some startup file. So whenever the PC is starting or rebooting, it will load the configuration from this file. So this concept applies to the other network devices as well. So the command could be different, but whenever you type any commands, just make sure you are saving it. So similarly, I have configured 10.0.0.2/24 on PC2. Then I saved the configuration, then I verified with show IP command. So it has the correct IP address. So now we have configured the IP address, we connected the cables. So now the next step is we need to make sure there is both PCs can able to exchange information. So when two machines talking with each other, depends on the purpose, there will be different types of communication. So any type of communication will follow some protocol. Protocol means nothing but set of rules. For suppose if two persons wants to communicate, they need to speak the same language. Language is nothing but set of rules. Similarly, computer machines can exchange files, can exchange emails, can exchange videos, can exchange audio, like similar function. There will be like so many types of data they will transmit So depends on the type of the data or the protocol, the rules will be different. So in this class we are using this protocol ICMP, Internet Control Message Protocol. So basically this protocol will be useful to test connectivity between two machines. So basically what happens in this protocol is, if you want to test communication between PC1 and PC2, you just go to the PC1 command prompt and you type ping 10002. So what you are telling with this command is, ping is an application that uses this ICMP protocol to send a hello packet to 10002. Okay, so then the packet will go on this physical link and will reach PC2. Once PC2 receives this packet, it will reply back with yes, yeah, I am here. Okay, it is just saying hello to each other. So we use this command or this protocol just to test connectivity between two machines. Okay, so when we issue the command ping 10002, what will happen is PC1 constructs a packet. So this is the actual data inside the packet. Okay, it's just asking, hey 10002, are you there? Okay, and it needs to add the address, right? So any letter should contain from and to address, like similar to the postal system. So there will be two fields. One is from IP to IP, another one is from MAC address to MAC address. So here the packet is going from PC1 to PC2. So from address will be, from IP will be 10001, from MAC will be whatever the MAC address PC1 has. Similarly, to address will be 10002 because we are sending this letter to 10002. Here we are typing ping 10002. So that's why PC1, when creating this packet, it is using the address which we have given in the command. And then it will put the PC2 MAC address. Once the packet constructs inside the system, it will go to the network interface card and it will travel physical link and will reach PC2. Once it reaches the PC2, so now PC2 will reply back. So when it is replying back, what will be the from address? 10002, because now PC2 is replying back. Okay, and the to address will be 10001 and the data inside that packet will be, hey 10001, yes I am here. Okay, so this way PC1 can check PC2 is alive and working or not. Okay, so in ping communication basically there are two packets. So one is ping request, another one is ping reply. Okay, so this is the output you should see when you type ping 10002 on GNS3 VPC. So here you see 5 lines. Basically what happened is, by default VPC will send 5 ping requests. If it receives ping reply for all the 5, the output will be similar to this. If you see sequence 1 2 3 4 5, so it sent 5 ping requests and it received 5, that's why it is showing like that. Okay, if it did not receive, you don't see the output similar to this. So you can see it sent 84 bytes and how much time it took is like 0.563 milliseconds. So this is round trip, not one way. So this time is PC1 sent a ping request to PC2 and it received the reply as well. So this value is total round trip time. So how much time it took for the packet to go to PC2 and plus how much time it took for the reply to come from PC2 to PC1. So this is the round trip. Okay, so basically when you type ping 10002 on VPC, total 10 packets exchanged. 5 ping request, 5 ping reply. So let's learn about some terminology. Instead of from and to address, in computer network we use source and destination. For suppose when we look at the ping packet, ping request. So we had like from and to, right? So in computer terminology, from will be source, SRC. To will be destination. Source is whoever is creating this packet, and destination is where this packet needs to go. Okay. So similarly, when in the ping request example, source will be PC1, destination will be PC2. For the ping reply, source will be PC2, because for the ping response, PC2 is constructing another packet. Okay. And destination will be PC1. Okay. So when the packet goes from PC1 to PC2, it's not the same packet. PC2 is generating another packet to reply. Okay. So this is the ping request. This is the ping response. Okay. So what is client and server? Client is someone who is requesting the information or initiating a connection. So in any computer unicast communication, unicast means one-to-one, right? So whoever is requesting the information or initiating the connection will be called as client. Server is someone who is responding with information or replying back to the original request. So in this example, when you type ping 10.0.0.2 on PC1, because PC1 is initiating or requesting the information, it will be client. As PC2 is responding or replying back, because so it will be server. So it's just the roles in this communication. For suppose if you go to PC2 and type ping 10.0.0.1, so now PC2 is initiating the connection, so it will be client. Okay. And who is server? Because PC1 is the target, it will be the server. Okay. So on any system by default, it won't generate any packets. The applications or softwares on the system will generate the packets. So in this case, if you want to generate the ping traffic, ICMP traffic, you need to use this command. This is the application on the PC that will generate these packets. Okay. So similarly, if you go to like any browser like Google Chrome and type https google.com, so here client software, PC will be the client and Google web server is the server. So from PC you are requesting a web page, Google server is responding back with the web page. So PC is client, server is Google server. Okay. So this is how the packet will look when you see it in the Wireshark. Okay. This is not the same example as I have explained before. So this is different machines, but the ping, this is the ICMP. Okay, ping request. So as you can see, it has IP values here. So this is the communication between 10.0.0.3 and 10.0.0.15. As you can see, source 10.0.0.193, destination is 10.0.0.15. That means a machine with IP of 10.0.0.193 is sending a ping request to a machine with IP of 10.0.0.15. So this is, you can see it in the packet, and you can also see in the Ethernet header, you can see the MAC address. So this is the MAC address of 10.0.0.193. This is the destination MAC address. So this will be the MAC address of 10.0.0.15. Okay. So these are the information needed to travel, information needed to be on the packet to go from one machine to another machine. Then this is ICMP ping request. Inside this you are sending this data. So this is, we call it as payload. So how you can imagine this packet is, So for suppose you are transporting some goods on a truck. So in the back of the truck you will have a cargo, and there you will have all your goods you want to transport. In computer networks it will be data. So this data we call it as payload. What you want to transport from one device to another device. And in the truck example you will have the engine. So this is headers. So in this example you have three IP, you have ICMP, IP and Ethernet. At Ethernet layer you have the details of from MAC address and to MAC address. At IP header you have source IP address, destination IP address. ICMP you have some details about the request. So in this case it is a ping request. Okay. So let's see how the reply packet will look like. So now 10.00.15 is replying back to 10.00.19. Here you can see it is a reply packet. So this machine received ping request and it is now replying back. So this is the reply packet. Also you can see source MAC address will be the MAC address of 10.00.15. Destination will be MAC address of 10.00.193, and this is the data. So this is the data saying yes, yeah, I am here. So this is the ping reply packet. So assignment for this class is build similar topology in GNS3. You can take any IP address you want, but just make sure both PCs have IP addresses in the same subnet. Okay. Then verify the ping connectivity between each other. Then install Wireshark on your PC and open command prompt and type ping 8.8.8. So 8.8.8 is open to internet for ping service. It is a Google IP. Okay, so it will always respond. So when you ping, you should see successful communication similar to the lab. So how you can capture this is go to this website Wireshark. You can download this software, it will be free. So once you install it on your PC, once you open the application, it will list out all the interfaces, and for the you should see some graph like heart rate graph similar to that beside one of the interface. So usually it will be the Wi-Fi if you connected to Wi-Fi. If you double click on it, it will start capturing the packets going from your machine. Then on the top you will have a space where you can apply the filter. So there will be so many packets going through your system. For now you only want to see this ICMP ping traffic. So you can just type ICMP in the top filter bar so that it will only show the ping packets. So once you apply this filter, issue this command, and you should be able to see the packets that I showed earlier. Okay, so that's all for this class.